Welcome to 10.2 Arithmetic Sequences. In this video, I'm going to follow some slides that go along with Blitzer's Precalculus 3rd edition, and we'll talk about some definitions and some techniques for solving some problems that deal with arithmetic sequences, and there are some example problems in here that we'll work out from top to bottom in great detail, not skipping any steps. And then in a lot of my videos, I go on to a notepad and work some additional problems, but I think that the problems that are in this pre-printed material are going to be sufficient to give you the tools, techniques, and the feel for this topic that should be able to take you anywhere you want to go as pertains to introductory level arithmetic sequences. So for starters, the definition of an arithmetic sequence, and you can read what's in this box, which is fine. The most pertinent piece of information maybe is this term, the common difference. And what an arithmetic sequence is it's still a sequence, so it's still a string of numbers or terms. The difference is that in order to go from one term to another term in an arithmetic sequence, there will always be a common difference between each successive term. For example, this term here, the first term, in order to go to the second term, you see that we're adding this d value, which is the common difference. In order to go from the second term to the third term, I can't speak all of a sudden in this video, or control what's on my screen, falling apart. In order to go from the second term to the third term, we've taken our first term and added two common differences. So the difference, if you'll pardon the use of that word yet again, what's the difference between these two terms? Well, this term, the third term, has one more d value that's been added to it. So if you took this expression, a1 plus 2d, and subtracted a1 plus d, you would end up with just d. In other words, literally, the difference between those two expressions is d. And that's the case here, and it's the case here, and it's the case here. It is the common difference between successive terms or consecutive terms. In order to move from the first term to the third term, we're seeing here that we started with the first term, and in order to get to the third term, we had to add two common differences. In order to get to the fourth term, we had to add three common differences to the first term. So the number of common differences you have to add to the first term in order to arrive to your desired term is always one less than the location, if you will, of your desired term. So we can say generically or generally speaking that to arrive at the nth term, you'll have to add n minus 1 common differences to your first term. Of course, we're going to see this with some actual numbers in it. This is just a little bit more formally written here as an actual formula for calculating the nth term in an arithmetic sequence, where a sub n is the destination, a sub 1 is your first term, d is your common difference. Write the first 6 terms of this arithmetic sequence. I don't think I'm going to write 6. I think you're going to pick up on what's happening here very quickly. So we have our first term. Our second term, a sub 2, will equal our first term, a sub 1, plus 1 common difference. So that's 3/4 plus 1 instance of our common difference, which is negative 1/4, and that equals positive 2/4, which reduces to 1/2. A sub 3. is equal to our first term plus 2 common differences, which equals 3/4 plus, again, 2 multiples or instances of our common difference, which happens to be a negative value, and that's okay. You can have a common difference that's a negative number. So we have 3/4 minus 2/4, which equals 1/4. We've started from 3/4, gone down to 2/4, and then down to 1/4. 3, 2, 1. Can you guess how many fourths are going to be in the next term? I'll let you do the arithmetic, but I'm pretty confident that a sub 4 is going to involve 0/4. So 0 will be the value of a sub 4, and then -1/4, -2/4, and so on. So that's the pattern. The pattern is very much facilitated by arithmetic. But when we take the noun of arithmetic and we use it as an adjective to describe a sequence, we pronounce it arithmetic. In example 2, we're trying to find a sub 60. We know what our starting value is, a sub 1. We know what the common difference is. How do I get to a sub 60? I can use my formula that says that a sub n is equal to my first term plus n minus 1 multiples of my common difference. I know that n is 60 because we're working with a sub 60. That's not a plus sign, that's an equal sign. There we go. We know what our first term is. In fact, I'm going to back up so that this stuff lines up vertically. I'm going to write what I was writing over there, I'm going to write it underneath. So let's write the correct stuff underneath. A sub 60, there we go. We don't know what that is, what we're trying to find, so that's why I've written it as a sub 60, but notice that we know, and you can see pretty easily here, we know what our n value is just by matching up the pieces. So n is going to be equal to 60. Right, a sub 1, we were told that that's equal to 8, plus, we're using that number 60, our n value that we noticed, times our d value of 6. Great. And what is a sub 60? Well, this is just arithmetic. All you have to do is take 59 and multiply it by 6 and add 8. I like to share little mental math tricks with you as I go along if they're not too involved, and so I will share one with you here. The number 8 is made up of 2 and 6. Obviously that's equal to 8. So here what I'm seeing is that I have 1 6, and here I have 59 6's, which means I have a total of 60 6's. And what's 60 times 6? How about 360? Don't forget the plus 2. And that's the 60th term in that sequence, that arithmetic sequence. Example 3 wants us to write a non-recursive formula for the nth term of this arithmetic sequence. So we want the formula. Part A, we know that the formula is going to look like this. A sub n equals a sub 1 plus n minus 1 times our common difference. This time I will go horizontally because part B is going to be right below it. I don't know what a sub n is. That's what we're trying to create a formula to help us find. We know what a sub 1 is. It's 6 plus. We don't know what n is yet. This is a very generic formula to help us find the nth term. Do we know what our common difference is yet? We don't. So here we need to make a note that says that our common difference is equal to a sub 2 minus a sub 1. And in fact, you can calculate the common difference by finding the difference between any two consecutive terms. As we talked about at the very beginning of the notes, I'll just go up there. Let's see. I was circling things like crazy up here. The difference between these two terms is equal to d. The difference between these two terms is equal to d. The difference, and so on, right? How do I find the difference between two terms? I take the later term and subtract the earlier term. In other words, I take the 6th term minus the 5th term. That would equal d. Or the 5th term minus the 4th term. That would also equal d. So what I'm doing down here is I'm using the 2nd term minus the 1st term. And in this problem, that's equal to 1 minus 6, which is equal to -5. So our common difference is -5. So I'm just going to keep going with my formula here and say that a sub n is equal to 6 plus n minus 1 times -5. That's okay as a final answer. Ooh, let me make a little modification here. There's an equal sign here that I'm going to erase, and I'm going to turn it into an arrow just like this one. There we go. We'll put that -5 and close it in parentheses, and I'm going to say that this is my final answer for part A. The negative that's associated with the 5, we could definitely take this negative sign and put it here and change that plus sign into a minus sign. So we could write this as a sub n equals 6 minus n minus 1 times +5. So I'm sort of factoring out the negative from my d value and causing it to impact the plus, which turns it into a minus. So in a multiple choice situation, you could see that final answer presented either of those two ways. You won't see both of them, one of them being option A and one of them being option B, and you have to choose the better of the two options. I don't think anyone's going to mess with you that hardcore, but could be that one or the other will appear as the final answer. For part B, use the formula to find the 20th term of the sequence. I'm not going to do that. Take a 20, plug it in for your n value, do the arithmetic. So you're going to have 6 minus 19 times 5. I'll leave that up to you. Write a formula, non-recursive, for the nth term of the given arithmetic sequence. I don't want to do this entire problem, but let me help you get it started. Remember that the formula that we're trying to create here is a sub n equals a sub 1 plus n minus 1 times your common difference. In this case, do we know what a sub 1 is? Yes, they're giving it to us. It's 6 plus n minus 1. We know that the other thing that we need is our d value, the common difference. We're not explicitly told what the common difference is. However, we've been given enough information to figure it out. This is a recursive formula for creating all of the terms in your sequence. It says that the nth term is equal to the previous term plus 5. So how am I going from one term to the next term? The answer is I'm adding 5. So my common difference is pretty easily identifiable in this recursive formula as 5. If the recursive formula that I have circled right here were more complicated, you might have to plug in an n value of 2 in order to calculate a sub 2. And then you could use the trick that we used in the previous problem and do a sub 2 minus a sub 1 in order to calculate your d value. But in this case, the 5 is pretty easy to find. All right, so you can put a box around that and then take a 20, drop it in for your n value, and calculate a sub 20. This is a space that allows for the derivation of this formula. We're going to go directly to the formula. Honestly, just add these things together and divide both sides by 2 or multiply both sides by 1/2. You can pretty quickly get to this formula, which says that the sum of the first n terms, this no longer says a sub n, it says s sub n, which means that we're summing or adding together the first n terms. Interesting formula. If you watched the video that came right before this one for 10.1, you know that a sub 1 represents the first term in a sequence, a sub n generically represents the last term in a sequence, n represents the number of terms in the sequence. How many terms are there in this sequence? 6. How many pairs of terms are there? If we took them and we paired them up, how many pairs are there? 3. There were 6 terms, and we paired them up and found there were 3 pairs. How do you change a 6 into a 3? Divide by 2. This division by 2 that you're seeing right here is this division by 2 right here. So n minus 2, n divided by 2 is the number of pairs of terms, and a sub 1 plus a sub n is the value of each pair, or in the last video we called it the pair value. So pair value times, well really it's number of pairs times pair value, n over 2 times a sub 1 plus a sub n. All right, so that's concept. That's strategy a little bit. That's structure of what's really happening. It's a little more conceptual. Now let's get into the process of it. Find the sum of the first 25 terms of the arithmetic sequence. Still caffeinating. Find the sum of the first 25 terms. Well, it's a sum, so I've got to believe that I'm going to be using the formula that's at the top of the screen here. And I know what my n value is, it's 25, and I know what my a sub 1 value is. The problem's giving it to me, it's the 7. Problem is, I don't know what a sub n is. I don't know what a sub 25 is. So that's the first thing we're going to need to figure out. Let's jot down a couple of preliminary notes. S sub n equals n over 2 times a sub 1 plus a sub n. N equals 25, we know that. A sub 1 equals 7. We know that. A sub 25 is what we don't know. So as I'm going back and I'm reading my notes later and I'm wondering what was the thought process to get to where I wanted to go, I can see now that I had a bunch of my given pieces of information, but I was missing that one. So let's figure that one out. A sub 25 is equal to, now I'm drawing on a different formula. This is the, in fact, we'll write that down again in a second. Remember, or recall, that a sub n is equal to a sub 1 plus n minus 1 times the common difference. I bet we could use this to figure out what a sub 25 is. We're going to need a sub 1 in order to figure it out. We know what a sub 1 is, it's 7. We're going to need n, that's 25, good. And then we're going to need d. We don't know what that is yet, but we can figure it out very easily. As long as we have our second term and our first term, we can do a sub 2 minus a sub 1 to find our d value. In fact, we do know both of those. So our d value is 12, which means now we know all the pieces of information, not all of those, we know all of these, which is going to help us figure out this one. All right, so a sub 25 equals a sub 1, which is 7, plus we've got 25 terms, so we're only going to add 24 multiples of our common difference, which is 12. So that is 24 times 12, which is 12 times 2 times 12, which is 12 times 12, which is 144, times 2, which is 288. 288 plus 7 is 295. It's more of that mental math stuff. I'm not great at a lot of it, but little ones like that, when you've got multiples in there, it's kind of nice. Okay, so we needed this a sub 25 value. That's great. Now we've got everything that we need. Let's plug it into our summation formula. S sub 25 equals, we've got 25 terms, which means we're going to have 12 and a half pairs, which is interesting. As we pair up the numbers in this list of terms, we're going to get to the middle, and that middle term isn't going to have anyone to partner up with. And so that's going to be the half of a term. But it's okay, because it's going to equal half of our pair value. I promise you it works out. You could write out a shorter list. In fact, you could go and redo this problem. I'm pointing at it like you can see it. I have to circle it. You could redo this. Try it where you're doing... Try it with 7 terms so you can see it play out, and you'll notice that when you pair up the 1 and the 7 and the 2 and the 6 and the 3 and the 5, that the 4 is going to be the number that's in the middle. That's the one that doesn't have any other numbers to pair up with. What's your pair value? 1 plus 7, that makes 8. What's half of a pair? What's half of 8? 4. So it's okay to have a half of a term, as long as you're including it, which we are here with 12 and a half pairs. Great. What's the pair value? A sub 1 plus a sub n. That's 7 plus 295. I see a 4-function calculator in my future. Let's see. So this is 25 divided by 2 times 295 plus 7. That I can handle. And even 302 divided by 2 I could do. Multiplying that by 25 though, I'm sure there's a trick for it. I'm not doing it. I'm not taking any chances. I've got my handy dandy 4-function calculator. 302 divided by 2 times 25 is 3775. Adds up fast, doesn't it? Started out with the number 7. Out of 25 terms, and you're into the 3,000 range. All right. Again, number of pairs, number of terms, value of each pair, starting with the first and the last and pairing them up. A sub 1 and a sub n, in this case a sub 25. All right, and we're on to the last page of this section worth of notes. This problem is a little bit tricky because we're supposed to find the sum of the first 80 positive integers. First thing you have to do is figure out what the heck are the first 80 positive even integers. Well, what's the first positive even integer? I'm going with 2. And the next one, 4. And the next one even, 6. What's the very last one? What's the 80th positive even integer? again, I think a great way to try to make that determination is to scale it down. Don't try to go immediately for the 80th one. After having written down what we just wrote down, ask yourself, what's the third positive even integer? It's a 6. The third one. The first one is a 2. The second one is a 4. The third one is a 6. Do you see the pattern? 1 times 2 makes 2. 2 times 2 makes 4. 3 times 2 makes 6. The term number doubled equals the term. Again, the term number doubled equals the term. So I'm pretty sure that once we get out here to the 78th, 79th, and 80th terms, that if we do some doubling, 80 times 2 makes 160, 79 times 2 makes 158, before that 156. I should not have written those in blue, I meant to write those in red. I'll put red plus signs between them. Those are the last 3 of our 80 positive even integers. Okay, let's see if we can find the sum. Let's see if we have enough information. The sum is equal to, and this is the sum of the first 80, so I'm going to put a little s sub 80 down there. That's equal to the number of terms divided by 2 times the first term plus the last term. I shouldn't have put the 80 there. I'm going to erase the 80. But there's the n, just the very generic version of the formula. Okay, now let's start filling it in. That's not an equal sign. Let's make it an arrow. So now s sub 80 equals, we know that we're going to have 80 terms, which means when we divide it by 2, we're going to have 40 pairs, and the value of each pair is 2 plus 160, first term plus the last term. So we've got 40 162s. So 162 times 40 is 6480. Nice. We've only got 2 more problems to do. So let's knock out example 5, the sum of the odd integers between 30 and 54. So this is another problem where it takes some preparation, right? We want to really understand which numbers we're working with, what are the terms, what's the common difference. So let's draw ourselves a little diagram, right? Just like we did here. This was my diagram for this problem. I'm going to draw one that's similar here. Find the sum of the odd integers between 30 and 54. Well, what's the first one? What's the first odd integer that's between those 2 numbers? How about 31? And the next one? And the last one? And the one before that? Right, so at least we have some idea who the players are in this problem. Okay, so that's what we're trying to figure out. This is actually going to equal s sub n. I don't even know how many terms there are, but this is what I'm trying to figure out. In the summation formula, do we need to know how many terms there are? Yes, the n value is very important in there. So we better figure out what n is. Is there another formula that we've been working with that has an n in it? There is. A sub n is equal to our first term plus n minus 1 times our common difference. Do we know what a sub 1 is? We do. Do we know what the common difference is? It's the difference between consecutive terms. What's the difference between 31 and 33? How do you get from a 31 to a 33? Adding 2. Or you can do use the little formula that we saw before, that d is equal to a sub 2 minus a sub 1. In this case, 33 minus 31, that's equal to 2. Let's write it down. A sub 1 is equal to 31. D is equal to a sub 2 minus a sub 1, which is 33 minus 31, which is 2. All right. And we know that a sub n, remember a sub n represents the last term. I don't know what the number of that term is. I don't know if it's a sub 12, a sub 15, a sub 22. I have no idea. But I know that the last term is 53. And that's important because I now know a sub n, a sub 1, and my common difference. What's the only value I don't know in this equation? N. And I need it. Why? Because in order to find the sum of the first n terms, I need a sub 1, which I know it's 31. I need a sub n, which I know it's 53, and I need n, but I don't know n yet. But I'm about to figure it out. So let's plug these numbers in and solve for n. What color? Back to red. Okay, a sub n is 53. A sub 1 is 31. Plus, don't know what n is, minus 1 times our common difference is 2. Great, subtract 31 from both sides. Divide both sides by 2. Add 1 to both sides. And we know how many terms there are. There are 12 terms. Now I can take my n value along with my other given information and plug it into the summation formula. I'm going to rewrite the summation formula and then I'll plug in those values. I might even switch colors. Very generically, right? I'm not putting in any numbers yet. S sub n equals n over 2 times a sub 1 plus a sub n, the first term and the last term. And then a little arrow, and let's calculate the sum of the first, it's not an n anymore, it's a 12. We know that there are 12 terms, 12 odd integers between the numbers 30 and 54. There are 12 of them, so we've got 12 terms. Equals 12 divided by 2 is going to make 6. That's how many pairs we have, and the value of each pair is calculated by taking the first term, which is 31, plus the last term here, which is 53, adding those together. And so S sub 12 is equal to 6 times 84. And leave nothing to chance. 84 times 6 equals 504. And that's the sum of the odd integers between 30 and 54. We needed to use both formulas in that one, and now we're bringing in sigma notation, which we know simply means adding up all of the terms. Which terms? The terms that are generated by this little formula right here. Okay, let's see. Let's see if we can use sigma notation and a sub n and s sub n. Maybe we're going to need all of those things. Let's see. Let's just see. I'm going to start with the formula for the thing that I'm really aiming at, which is s sub n. S sub n is equal to n divided by 2 times a sub 1 plus a sub n, the first term and the last term. Sorry, my n's aren't coming out better. Do we know how many terms there are? In other words, do we know what this n value is right here? Are your eyes traveling over here and looking, trying to determine how many terms there are? What's the lower limit on the sum? What's the upper limit on the sum? what will our index of I be doing? Where is it starting? Where is it ending? Starting at a 1, finishing at a 20. How many numbers are there, do you think, from 1 to 20? So it's safe to say here that our n value is 20. Do we know what a sub 1 is? Do we know what our first term is in our sequence? We don't know it. Could we calculate it? Definitely. How? We take our I value of 1 and we plug it into our formula. So I guess we could maybe fit this right here. Maybe not. Let's go to the next line. A sub 1 is equal to 6 times the I value of 1 minus 4. So a sub 1 is equal to 2. And a sub 20, the last term in our sequence, which we need to know, is, or can be found by taking 6, multiplying it by 20, subtracting the 4. 6 times 20 is 120, minus 4 is 116. Do we have all the necessary information? Do we know what n is? Yes, it's 20. Do we know what a sub 1 is? It's 2. Do we know what a sub n is? In other words, a sub 20. We do. It's 116. We're good to go. We don't need the a sub n formula in this case. We were able to figure out everything that we needed using our sigma formula right in here to generate each term. So finally, s sub 20, the first 20 terms added together. 20 terms divided by 2, 10 pairs. First term, 2, plus last term, 116. The value of each pair, 118. 20 over 2 makes 10. 2 plus 116 makes, as we said, 118. This I can do in my head. Multiplying by 10 means I just tack on a 0, and the indicated sum is 1,180. The more problems of this type that you do, and we saw a pretty good variety in these 4 pages, the more of these problems you do, the more familiar with the little maneuvers that you're going to need to do. I find it very satisfying to solve these problems because I know that when I'm working with problems like this, there are only so many varieties that I'm going to encounter. So you want to do enough of these that you start to get bored, because when you read the problem, you already know what you're going to need to do. Then it's just a matter of going through this stupid process in order to get the answer. Right? That's where you want to be. Frustrated by how smart you are. Get to it, and I'll see you in the next section. Thanks.